Back it up, dog pounds, back it up. We are going to zoom out a little bit when we talk about how lipids are absorbed into the bloodstream. We're going to do this because there are new anatomical structures that we have to be aware of. First of all, you remember, I know you do, you remember that not only do small intestine cells have microvilli on them to increase surface area so that they can absorb more stuff, which makes sense since small intestine is absorbing 7.5 liters of stuff every day. We also have giant structures called villi lining the actual, I don't know what I'm trying to say. The epithelium, this is representing individual epithelial cells. Each single cell has microvilli. You can barely see my little microvilli. This is a line of epithelium. Microvilli are found on individual cells. Villi are finger-like projections made up of multiple epithelial cells and other stuff, because holy lamina propria that you actually have inside of here. Now, you also are going to have a blood supply. The whole reason why I'm drawing you this picture, this little reminder, is because in addition to that, you have lymphatic vessels called lacteals. And the lacteals are found projecting up into the, what is this called? Villus. The lacteal is actually a projection of lymphatic vessel. So the lymphatic tube projects up in here, and then you still have all of your blood vessels. So you can't forget, then in addition in here you have a whole net, and I can't draw that. Like, how do you draw a net of blood vessels that are also coming up inside here? Okay, and you can imagine it is a net. It's not just a U-shaped tube. Did I just make it worse? But the point is that we also have blood in here. I totally made it worse. I'm just going to erase that. Just don't forget, there's blood up there too. Blood. Bloody hell. It's in there also. Okay. Fat in my lumen. Don't forget, fat globs are going to glob together in globs. And so you have to have bile come in and break up the globs. And once the bile comes in and breaks the globs into smaller globs, then you're going to have lipases that are going to break your fats into their component parts. You remember this from Bio 1. Fats are made of fatty acids and glycerol. So your lipases, fat breaker uppers, lipases are going to break your fats into fatty acids and glycerol. Now, fatty acids and glycerol, guess what? Do we need any transporters to take something that is hydrophobic and get it through the cell membrane? Nada. So what we're going to do, and I do not have room to show you this, but we're going to take our fatty acids, and they're just going to diffuse through. They do need to be processed. So fatty acids enter the cell, diffuse into the cell. They're processed in the smooth endoplasmic reticulum. Remember, that's where we process fats. Nice. And then they're packaged in the Golgi body, which this all is review of cell parts and what they do. So the Golgi bodies are just going to package up those fats, and then they're going to be exocytosed into the lacteal, which is the whole reason why I had to draw you this anatomy piece. So the fats ultimately are going to enter the lacteal. They're not entering the bloodstream. However, we know that all our lymphatic juices that get dumped in, they all are going to enter into your cardiovascular system up by your sternum anyway. So the fats are going to get into your blood. They just go through the lacteal first. All right, so you now have lipids and everything in your system. So who cares? All of these will allow us to carry out metabolic processes. We're going to look just at glucose. Glucose homeostasis is really interesting. Connects to our kidneys, connects to the liver, and we have some serious issues with glucose homeostasis, especially in our country because we have a major type 2 diabetes adventures happening on our planet. Okay, so let's talk about glucose next.